All right, so let's jump into the Hack the Box lab. Today we're going to be looking into the framework Better Sliver. I'm going to be demonstrating a technique so you can create persistence on a CTF lab. The focus on this lab is for you to establish persistence via a shared backdoor. This is a control lab environment, hack the box CTF, so everything is control and is for educational purpose only. And the main goal is to show you the difference between a reverse shell, raw N64 executable binary versus a little bit of a higher technique, which is a shared backdoor. So now a little bit of context about the framework. This is an open source GitHub repository, so you can always download or clone the repo into your Kali machine or whatever you may be using, whatever flavor of Linux. So now it is written in Go, so you might have to isolate different tools that may be written in Go as well, so they don't compromise each other. I would suggest some sort of environments. But nevertheless, this tool it's used in red team operations and also adversary simulations. And the main function, if you may think about this tool, is to manage remote beacons, to execute commands through encrypted channels. So that might sound a little bit what are you talking about, right? I am gonna be talking to all the commands that I'm gonna be doing. I'm gonna be telling you what I'm doing, so everything can make sense from the encrypted channels to the implants or beacons. So to give you a little bit of context before we do anything, right? I do have a database MySQL database ready here for so we can utilize, and this is going to be the way we're going to be uploading our payload into the remote machine. Now I did show a video where I just uploaded a raw NC64 and then we can set up a listener and get a reverse shell. But on this video I'm going to be uploading what we're going to be calling an implant, so we can implant it into memory, run it, and then we have access to a backdoor. So the way we're going to be doing that, we're gonna be using Sliver server to generate a payload. I am gonna copy this command and run it. It does take a few minutes to generate, so I'm gonna generate it. Once it's generating, I'm gonna tell you what I am doing. So first of all, this command is essentially if you use MSF Venom, it's doing the same thing. It's creating or generating a payload. The payload is simply just calling our home 10.10.14.78. We're gonna give it a 4555. The OS is gonna be a Windows. Save everything to this directory, to the escape2 C2 directory. With let's see. There's nothing saved right now. So right now we're generating a payload. We're passing mTLS. This is a mutual transport layer. So we're telling it everything's going to be encrypted through a encrypted channel, which is going to be a mutual channel. The M is mutual. Mutual meaning both ways are going to be encrypted. So what this is going to be generating is going to be the implant. So an implant, once it's generated, is just what it sounds like. It's an implant. It's nothing. It's just something. It's just going to be something sitting inside the machine. It's not executable. It's not being executed unless we execute it, right? So an implant is simply a program that has been implanted somewhere, and it's just sitting there. It's not malicious until you run it. It's kind of like living off the land, if you may think it like that. It's taking space, of course. It's taking resources, but it can always sit there without being executed. So what we're going to be doing, once we generated that implant, we're going to upload it into the remote machine via our MySQL database. So now, for a little bit of context, we are running as SA, which has administrator rights and can use advanced SQL server commands, such as enabling the XP command shell. Now, this video is not about MySQL, so I'm just going to copy and paste. But essentially, this command, we're just configuring or enabling the command XPCMD shell. What essentially is going to allow us to do is to transfer files, upload files. But in case, of course, we're gonna be downloading a implant to the remote machine, with this enabling this. So I'm gonna go ahead and copy that. And now we have access to, we have enabled the XPCMD shell. If we don't utilize the MySQL, about every minute or so is going to disable the XP, so we're going to have to re-enable it. So right now, let's go back to our Sliver session. As you can see, we have generated a payload, which I know it says implant. So the implant has saved into the designated directory, which should reveal here, envios links.exe. So remember, this is right now is just an implant, nothing malicious yet. So what the instructions on this implant is to communicate through a mutual channel to this IP to this listening port. So now we have created that direction of where to communicate to, right? So we need to open that listener to listen for this beacon, of course, for this implant. So now let me touch a little bit about beacons. When we upload the implant into the remote machine memory, and for this example, we're going to be triggering the implant manually, but we can always, run it as a scheduled task or something that it can execute. But since we have access to the remote machine through the MySQL, we're going to simply execute this manually, right? Once the implant has executed, it's going to become a beacon. A beacon is simply something that is going to communicate back and forth through the encrypted through the encrypted channel. The encrypted channel that we're going to start is going to be encrypted is mTLS our L host 10.1478 -- L port. This is where we're going to be listening for that beacon. So as you can see, we have a job. There's a listener waiting for that beacon. So now we have everything set up, right? So the next thing we need to do, we need to upload the implant to the remote machine, execute it. Once it's executed, the implant is going to become a beacon. The beacon is simply going to just call home or call to our server, which is our C2 server. So it's going to say, hey, I'm already executed, so I'm just checking back and forth with you to see if you have something for me to do, right? It's just waiting for us to pass commands so the beacon can execute commands remotely, and everything through the encrypted channel. That way, the operator, us, we're not in the middle of the main us executing commands. Kind of like a man in the middle, if you want to think about it. We're executing commands from our Kali. Our Kali is sending those commands to the server, and the server is sending those commands by the beacon. The beacon is taking those commands, right? Perfect. So let's now, and as always, if you have more questions about that, you're gonna go Google it and Google more stuff in detail. But let's utilize our MySQL again to respawn this. Perfect. Okay. And we have this channel. So now let's set up a server so we can transfer our implant. Let's set up a Python. Let's utilize the exec certitail to upload that. We're gonna try to upload our implant into the temp Windows temp directory to see if we can write to the file. But we need to substitute your right beacon, and then we also need to change our IP. It's 1478. Perfect. Let's see if we can enable. So the XP has been disabled, so we need to enable it again. And again, this just enables for every a minute or 30 seconds, so you have to kind of do the commands right away. Perfect. So now let's go back up. There they go. Now it has transferred the ambitious linked executable into the remote machine to the Windows 10 directory under beacon, and we have renamed it beacon.exe. So right now the implant is in the remote machine, right? So it's just waiting for execution to become a beacon. Once the beacon has been established, then it's gonna check to us. It's gonna check what to our server, to our command and control server. So the next thing we need to do, of course, is to execute manually our implant to become a beacon.exe. If it doesn't work, we need to enable the, there it is. It worked right away. So here it is. So we have the ambitious links. And if we do sessions, the transport that we set up, it's the mutual transport layer. This is the IP of the machine, 10.129.162. I just generated this port, and it has created or given us the host name and the username, the Windows, and it's alive. So what's going on right now, the beacon has communicated to our C2 server, and it's ready for us to use that ID that has created. And this is in case, the purpose for this ID is in case you have multiple beacons communicating to your server. You can that way you can have persistence on different machines at the same time. So if we want to utilize this session, we just gonna do use and then the ID. And then you want to do shell. It's going to ask you, are you mature or are you an adult? You just want to say yes. So now you're essentially you're in the remote machine. And this is the purpose for this video, right? So the purpose of this video is for you to see the difference of a remote raw N64 shell versus a little bit more advanced technique such as a command and control persistence shell.